Next to electric and hybrid electric vehicles, we still have some distance to overcome. Lithium-ion battery is developed from lithium element, chemical element. On the periodical table, symbol Li is atom weight 3, so it's number 3 in the atom table, periodical table. So it's very light. It's very light, and it's highly reactive. So with high energy density. So that's why lithium-ion. The batteries were developed in the 1970s, but it was not very stable. And after that, people started to use lithium metal to design the battery, but it's not safe and not practical. So lithium cobalt oxide and graphite are now used for lithium-ion moving electrodes. So that's what we use today. The lithium-ion battery has a slightly lower energy density than lithium metal, but it's much safer. And this one started by Sony in 1991. And that is when lithium-ion battery becomes more and more popular in consumer electronics. The U.S. Department of Energy, as I mentioned, have office support battery research. In the past a number of years, the focus has been on lithium-ion battery. Their working goal is to reduce the cost, increase reliability, increase the life cycle time, and improve energy density. So if we look at the chart over here, the current we have available energy for a 3.4 kilowatt hour, which is for conventional HEV, not too much for PHEV. For PHEV, you need to double to triple this number. The cost is roughly $1,000 per kilowatt hour. And the cycle is 1,000. So this cycle life of the battery is mean that if you discharge the battery from 100% to 0%, and then you charge them from 0% to 100%, you do another discharge from 100% to 0%, you can do 1,000 cycles. So apparently, if you don't go all the way to 0, it does not consider it as one whole cycle. Therefore, the cycle life could increase significantly, normally from 1,000 to a few thousand, say 4,000 to 5,000 cycles. That's called a cycle life, 300,000 cycles in HEV, where you limit your discharge SOC state of charge between 40 to 80%. Calendar life, at least 3 years or more, but we don't have enough that yet. The system volume is 70 liters. So that's the current status. So in order to have these batteries become more applicable for PHEV, we need to work towards an even higher goal in the long term, in the near term and the long term. For the same 3.4 kilowatt hour, if we put them on a passenger car, you can probably drive 10 miles. The goal that DOE set for the battery manufacturers is to reduce cost to $500 per kilowatt hour. The cycle life increased to 5,000, and calendar life is okay. A cycle life to 300,000 for HEV cycles, for EV cycles to 5,000. 10 years plus life, and 40 liters, 60 kilograms. That's the short-term goal. The long-term goal is that to develop roughly 11 to 12 kilowatt-hour pack that can reach $300 per kilowatt-hour. So those are very, very stringent goal and a very aggressive goal that battery manufacturers have to work hard on to achieve this type of goal. However, with the demonstration projects being supported by DOE, with the market open up, with more and more vehicles produced, you are going to see the price of these batteries drop. That's for sure, because mass production is going to reduce the cost, manufacturing cost. However, original materials such as lithium may be of concern, because at this moment we don't use a lot of it. But if we do produce 1 million PHEV per year, that demand of lithium could grow significantly. So there's some other issues the industry and the government has to look at. As we mentioned that lithium-ion batteries have many advantages. They are considered the only viable solution for PHEV at this moment. So that's probably 99% of the people would believe lithium-ion battery is the only viable solution. Their advantages include high energy density, which is about 1.5 to 2x nickel metal hydride, 3 times lithium-ion batteries. So high energy density will give you much smaller size, smaller weight to be used for PHEV. This battery also have a very low discharge. If you charge the battery and leave them alone for a long time, they will keep their energy with very minimal self-discharge inside the battery. They have a pretty long life cycle in comparison to lead acid. Typical 300 cycles for lead acid, but this one can go up to 1,000 cycles, and even better than nickel metal hydride battery. It does not have a memory effect. Therefore, you can charge and discharge from any percent of SOC. It will not affect the total capacity of the battery. And the cell voltage is also a little higher. It's 3.2 volts in comparison to 1.2 volts, 1.2 volts for nickel metal hydride and lead acid batteries. Higher cell voltage means less cell is needed to form a high voltage. Therefore, you may be able to eliminate the DC-DC converter in an HEV system, and you also can achieve a better efficiency because the elimination of the DC-DC converter and because of high voltage in your system. The example shown on the diagram is an 18650 cell, and that nominal voltage is 3.2 volts. 1.5 ampere hour, so the total energy is 4.8 watt hour per cell. The lithium-ion battery, you can see that the 228 watt hour per liters, 120 watt hour per kilograms, but the lead acid is 85 watt hour per liters, 39 watt hour per kilogram. Those are the ideal nominal ratings of a battery. But there are actually a number of issues related to lithium-ion battery. Those included safety, capacity, fate, and life cycle. The safety and reliability in a few areas included electrolyte spill, smoke, fire, explosion. Those can happen if they are not controlled and handled properly. Capacity fate is where you see less capacity every month or less capacity every year. Whether the battery would provide sufficient mileage at 10 years, in 10 years' time is a question. And the life cycle is that if the battery, whether the battery can last the same lifetime as the powertrain and the vehicle itself. So those are the things that are of concern to us. And the pain is actually greatly amplified in a system, in a larger system, where you have thousands of these batteries in parallel and a series. Okay, so let's take a break now.